One of the major skills we intend to teach in this video is hit turn. That is a technique of rotating the bar 90 degrees every time the hammer comes down. Why do we want to use this technique? It has several advantages. One, it keeps the stock square, and square is the most contained form you can keep the steel in, which is going to conserve the heat. Also, hit turn generates heat within the bar from impact. It's very important as you use this hit turn technique to move systematically down the bar. If you just shove the bar back and forth, slapping wherever you can, you're going to lose heat quickly, and you're going to have to work much harder and take many more heats. To make a hit turn wedge, start by putting a very small amount of steel on the die and hit turning down to about half the dimension of the bar square. Then advance the bar on and form a square taper to that original thickness. Advance again and forge it down again, and advance until you're right up against your tongs, and come back for a last time. Once you have done that, put the bar on the die and forge from the end to the thin part. By understanding that what we manipulate as blacksmiths is the volume of a piece of steel, I often think of the steel as an unbreakable bag full of goo, and my job is to push the goo into the right place so that when the steel stops being hot, it becomes the part. The squares are the easy part. They are one length that is the height of the parent stock bar. This is a regular rectangle, but this is a taper, and that's going to require some math. To understand a taper, let's look at it physically. If we take these two parts of this taper and we fold one over the other, we get a rectangle. We've done this physically now. Let's look at it mathematically so that we can make any taper we want. Let's look at our taper in terms of our tong reins. If we start here and we label this side of the tong A1, and we come down to the other end, which is considerably smaller, and we call that A2. If we add A1 and A2 together and divide by 2, we will get an average. By deriving an average for our taper, it allows us to treat the taper as a constant dimension. Now we have the average cross-section of the taper, but we don't have the volume yet. For that, we need a third dimension, the length. Now we're ready to lay out the tong stock so that we can mark it with a marking bar. We're going to put one length that is equal to the height of the material for the jaw, and be generous with the jaw. And then we're going to mark that square across the bar. That is very important that you have the square orientation so that you can see where to put your marking bar. To get that length, we need to determine the area of our parent stock. This is a round, so our formula for area is pi r squared, and also equally useful formula is a squared times pi over 4. In order to make a pair of tongs, I need tong stock. So the first operation will be to convert this round bar into this 3/8 by 7/8 flat bar. Knowing the volume of my tong stock, I can determine how much length I need for each part of the tong. And mark that with the marking bar. This tool is a round back flatter. It's a dome shape with a flat shape on the opposite side. The first step in this operation is to pull this part of the tong back. Driving and flattening and driving and flattening until we've gone down to within 5/8 of an inch. Now that the reins are drawn out, we want to adjust the relationship between the jaw, the bit, and the boss. Go deep enough so that you are slightly less than the material you are going to use in the tongs. So one of the things that a punch can do when you're punching under the power hammer or on the anvil is get stuck. One of the ways to alleviate that is lubrication. After the light tap, remove the punch, check the hole to see that you did clear the slug, and there we have it. It's sometime later. Our tongs are cooled. We allowed them to air cool because they're made from 4140. We did not quench them because 4140 is a medium carbon steel and will harden when quenched. A wider edge will give you more bearing surface and therefore less stepping as you forge. Okay. Next tool we're going to make is the double side set. The advantage of the double side set is it has both a left and a right-handed side set. I want mine to have about a 12-inch handle for good separation. I want the handle to be about a 1/2 inch square. Therefore, I need about 3 inches of material in between the 2 1/4 on either end that are going to be the side set. Here's the marking bar we forged for this video. In order to turn it into a marking bar, we need a striking surface that is opposite a corner. The way to do that is to take a corner and grind it off.